So every vector may have two components, not necessarily. If the vector doesn't, it's not on the axis, then it may have, or it does have two components. Okay, so for example, let's say we are going to have a vector that is pointing in this direction, there, in that direction there. Okay, and we're going to call that vector, we're going to call it F1. We're going to call that vector F1. All right, that vector is in none of the axes, is in between the axes. Do you understand? It has one angle between the x and the y axis. Let's draw quickly the axis so you can know and you understand what I'm saying here. No, there. Not there. Let's take this one here to draw. This one is the x-axis. Okay. That one is the x-axis. And let's do another one for the y-axis. So it must be perpendicular. There we go. Let me just move it here and do it exactly perpendicular. Can you see that? So this one here, x-axis. This one here, y-axis. That force F1 is on none of the axes. That force is in between the axes. It means that force has two components. We are going to break that force into components. The x component of force 1 and the y component of force 1. So all we have to do is to take it to the x perpendicular down here. It's like the shade of that force. Did you see that? This one here, that is right on the x-axis, that is coming from F1, is what we are going to call F1, but in x, because it's now on the x-axis. We took it to the x. It is called the component of the force 1 in the x-axis. Sometimes they call it a horizontal component. Do you understand? And if you take that force to the y-axis the same way perpendicular, you take it here all the way there to the y-axis, you also have here the y component of F1. So who is that green line? F1 in the y-axis. Okay, so now we go once more to tricks. If we have this angle here, then we may calculate algebraically F1 in x and F1 in y, isn't it? So how will be calculating the F1 in x? This one is the adjacent side, so it's cosine. So F1 in x is going to be equal to F1, which is the hypotenuse, multiplied by the cosine of theta. This is how we calculate the horizontal component of F1. How do we do that now for the vertical component? That one will be the same as this one. It's the opposite side, isn't it? So this one will be F1 in y is equal to F1 sin theta. That is how we calculate the components of a vector. Very easy, my lovely, beautiful children. Very easy and also very important. So this is how we calculate components of a vector.